Good morning, class. Today we are going to be learning about motion maps. Motion maps are a third way to represent our motion. We have looked so far at the equations and at graphs, but motion maps are a little more pictorial. They're a pictorial model, as we read in chapter 2 about the different models. So let's start off with a moving car. So what you see here now is multiple cars, but actually they are the same car. What we're doing is we are looking at the cars at different seconds. So the first car here is at second 0. And the second car is there at 1 second. And the third car is at 2 seconds. And the third car is there at 3 seconds. So this lets us know as if we were, or this communicates to us something like taking a picture at each second. So because the car is not in the same spot at all seconds, I know that the car is moving. Another way to do that is maybe to give it some like wind lines or something, right? Something like this, okay? Now, the cars are all essentially the same distance apart. So this means that they are moving the same distance in the same time. Delta x over delta t is the same. So this means that the car is not accelerating. It is moving at a constant velocity. All right, let's change the velocity a little bit. Let's see how that would look. Okay, so I have moved the cars around. Notice we only have 3 cars. So the car is able to get to the same position at the end of my first drawing as it is now. So this means that it's moving faster. In 2 seconds, it is able to get to the same distance, but in less time, right? The delta x is the same, but the delta t is smaller. So what if the car was accelerating? What would that look like on a motion map? Let's try that out. I'm going to move my cars around and show you what it looks like. Okay, so now the first 2 images of our car, the 2 first snapshots, are closer together than they were before. And the first second, between the first second and the second second, the cars are much, much farther apart. Notice the wind lines have also got faster. So we know that it's moving faster, right? So we start off with 0 to 1 second being close and 1 second to 2 seconds being farther away. This means that as we take our pictures, the car is getting faster and faster because the delta x is getting larger for the same delta t, right? So I can represent that. So here we have a delta x that's small over the same delta t. And here we have a larger delta x over the same delta t. So this communicates to us that each time, and if I was to continue to draw this, let's say the acceleration was constant, we would keep seeing the delta x get larger and larger and larger. And actually, it would be a parabolic function, right? That's what we would see on a position versus time graph for an accelerating object. Now, motion maps can be complicated if every time we have to draw this car over and over and over again. So it is much, much easier if we represent any object that we are using as a dot. Okay? And then we will represent how quickly it is moving with a vector. So a vector is an arrow that represents both its magnitude and its direction. So here on my dot, I'm going to draw the vector going to the right. And here's my velocity. And now I will draw the second dot. It has gone a certain distance, and it has the same velocity, and so on and so forth. But let's say that our object is slowing down, so it moves that same distance, but the velocity is getting smaller, right? Which means that it won't have traveled as far. And it gets a little bit slower, so the vector gets smaller, and then it comes to a complete stop here. And it stops there for another second, and then it begins to move in the opposite direction with a negative velocity and begins to move back this way. So motion maps can get a little confusing if you are changing direction here, but this is how you would draw it. So notice in the very beginning that I was moving quickly, and then I slowed down, so the distance between my dots got smaller, and then I moved even slower, so the distance between it. Now when I stopped, I drew dots just on top of each other, and then I began to move in the opposite direction one more time, and I kept going. All right, so this is the basics of motion maps, and you'll need to know this for the future as we do some of the problems in class.